Okay, so I think a couple attendees are still trickling in, but in the interest of keeping on schedule, welcome everybody. Just a couple of housekeeping items. Whoops. So presenters, please keep yourself muted. If you don't, I'm going to put you on mute. Attendees, if you have any questions, there's a Q&A at the bottom of your screen. If you can write the name of the presenter that you're addressing your question to, that way they know who you're asking the question, they can answer you in particular. There is a little bit of overlap with some of the topics. We just want to make sure that the right presenter is answering the right questions. So just make sure that you're writing, for example, Eric is our first presenter this morning. If you can write Eric followed by your question, then we can monitor that in the Q&A. And if you have any other questions or comments for me with some tech support, you can use the chat. So with that, I will pass it over to Tara.
Thank you, Amanda. Good morning and welcome. And my name is Tara Carpenter, and I'm the coordinator of the Long Point World Biosphere Reserve Research and Conservation Conference. The Long Point World Biosphere Reserve Foundation acknowledges that we meet on the traditional territories of the Attawandaron and Haudenosaunee and Anishinaabe people, and show respect today to those communities that the nations of the Grand River Territory and the Mississaugas of the Credit, which treaty lands include the Long Point World Biosphere Reserve. I would like to thank each and every one of you for tuning in today on this balmy autumn day, considering how beautiful it is outside. And you still chose to join us today shows me the high level of interest in conservation and research in our area. The sheer importance of this goes beyond Long Point, goes beyond Norfolk, and goes beyond the Lake Erie watershed. It is important for the health of our environment and ultimately our children's future. I would like to thank all today's presenters for their hard work and passion in what they do. And I would also like to thank the Long Point World Biosphere Reserve Foundation Board of Directors, volunteers, Rick Levesque, the Biosphere President, Sandy Jukes, the Biosphere Administrator, and especially Amanda House, the Director of the Board, for being our technical support today. The Long Point Biosphere Reserve is an area of global ecological significance that makes an ongoing commitment to the United Nations to strive for sustainability. Visitors and residents are inspired to coexist in harmony with nature. The Long Point Biosphere Reserve is in Norfolk County on the north shore of Lake Erie in the heart of Carolinian Canada, hosting more endangered species per capita than the rest of Canada. It is home to the greatest number of plants and animals and the highest density of wildlife in all of Canada. The Long Point Walsingham Forest Priority Place was selected by Environment and Climate Change Canada because of its high biodiversity, large number of species at risk, highly engaged local conservation community, and a significant environmental threats. The Priority Place Initiative is implementing the pan-Canadian approach to species at risk conservation through an agreement between federal, provincial, territorial governments across Canada to conserve species and their habitats. So our first presenter today, I would like to introduce Eric Cleland, and I'm just going to read you his bio. So Eric Cleland is the director of the Nature Conservancy of Canada's Invasive Species Program in Ontario. Eric has developed and led the operational delivery of Canada's largest invasive Phragmites control program, unique to the Long Point Priority Place in its ability to use herbicide to treat Phragmites growing in aquatic habitats. Eric grew up in the Long Point area and enjoys seeing the restoration of these globally important habitats that are critical to the sustenance of species at risk and wildlife not yet at risk. Thank you, Eric.
Okay, are we good to go? Can you see my screen? Okay. Great. Well, thanks very much for the introduction, Tara. It's my absolute pleasure to be here this morning. There's no place and no group of people I'd rather be talking with and talking about our work with than the folks who care about the Long Point region. I'm going to speak to you a bit today about a project that's been going for the last 4 or 5 years in the Long Point region, where the Nature Conservancy of Canada has had a partnership with the Ontario Ministry of Natural Resources and Forestry and Environment and Climate Change Canada through the Canadian Wildlife Service to control invasive Phragmites in what started out as the coastal wetland complex at Long Point and then has now expanded into the associated watersheds. So a little background about the enemy at hand here. Phragmites australis is a native to the European area. It's a perennial grass. It spreads readily by seeds, but also through rhizomes and stolons, so chunks of roots and live stem as well. So it's a voracious enemy on the landscape and easily chokes out other vegetation once it's established, including all of our wildlife, but in more concerning is our species at risk that we have in the Long Point region. It's also allelopathic and a strong nutrient competitor, which means it can actually fight off native vegetation and then steal their required nutrients to give itself a bit of a competitive advantage in the growing environment. Way back 15 years ago in 2005, Agriculture and Agri-Food Canada identified Phragmites as the worst invasive plant to hit the shores of Canada. And as I mentioned, it is a European native, and to date, there are no natural controls in North America. So, sorry, the slides are jumping here a little bit. Why Long Point region and why have we focused such a significant project in the Long Point region? Well, as many of the folks listening today probably realize, Long Point has more designations assigned to it than just about anywhere else in Canada. It's a World Biosphere Reserve. It's an area of natural and scientific interest, both for earth and life sciences. Has extensive provincially significant wetlands, the largest collection in the lower Great Lakes. It's been identified as a Ramsar significant wetland site. And of course, it's also an important bird area for a number of resident and migratory species. The wetlands and unique habitats of the Long Point region are home to over 23 species at risk. And those who have been here in the spring and fall have seen the incredible convergence of waterfowl and shorebirds passing through the Long Point region on their way either north or south for either their wintering grounds or their summer breeding grounds. So it really is a very special place, both in a year-round nature, but also at only specific points in the seasons. There's a very high number of provincially rare species and vegetation communities here that require protection. And I think what's really critical and important is there is a significant opportunity for landscape scale impact here. With so many good organizations, landowners, and interest groups that want to see conservation done in the Long Point Walsingham forest area, it's really important and a really unique opportunity for us to get as much work done in a collaborative fashion. So a little bit of background on the project itself. The invasive Phragmites ER project was started way back in 2015. Discussions between the Nature Conservancy and the Ontario Ministry of Natural Resources and Forestry around the incredible impact Phragmites had had to the habitats at Long Point. Working together, we were successful in achieving an emergency registration from the Pest Management Regulatory Agency of Health Canada to apply the herbicide Roundup Custom to aquatic habitats, Phragmites growing in aquatic habitats at the Long Point region. This is a very similar product and application method that has been used for decades on the other side of Lake Erie on the American wetland environments. This project has been going for 5 years, including just finishing up a successful 2020 season, and has a number of important agencies supporting it along the way, including Ducks Unlimited and local groups like the Long Point Waterfowlers Association, the Long Point Ratepayers Association, private hunt clubs like the Long Point Company and the clubs at Turkey Point in the Lower Big Creek area, monitoring and research and implementation partners like Bird Studies Canada, and a number of other members of a group that we call the Long Point Phragmites Action Alliance, which is almost 30 organizations strong that have an interest in controlling Phragmites in the Long Point region. Of course, when you're going to receive a special permission for a project of this nature, it's important to be undertaking comprehensive environmental monitoring of the work you're doing to make sure that we're having the best positive impact in the environment with the least potential for harm. And MNRF and NCC and the Environment and Climate Change Canada have worked very closely with the University of Waterloo and had some really positive monitoring done over the last 5 years of the work that we've undertaken. Of course, there's been a lot of support from the public, our First Nation communities and partners, and a number of neighboring jurisdictions, which we're very happy to see Canadians cleaning up our coastal wetlands as well. So how do we actually go about treating the Phragmites? Well, there are 3 main tools we use, and you can see them here on this slide. The first and quickest way to get the job done is to use aerial application. The other unique thing about this particular project is it's also the first time herbicide has been applied aerially in Canada for an aquatic plant program. So a number of firsts on this project. We've contracted a few different companies over the last few years to conduct a helicopter-based control work. And it's a really efficient way of getting a lot of area covered. Now, naturally, there are a number of areas that a helicopter can't access or isn't appropriate to use as the treatment tool. And we have an amphibious track machine called a Marshmaster that is used to access those other tighter areas. And in the bottom right corner, we also use a shallow draft John boat with a marsh motor on it and a spray system to get into those areas that require a targeted treatment. So if you're going to fly a helicopter and spray an herbicide out of it over a significant habitat, it's very important that you're doing it the most responsible way absolutely possible. And so we have a number of species and habitat conservation measures that we build into the treatments to make sure that we're putting the product where it needs to go and only where it needs to go. And we start by doing a calibration exercise. So we actually lay out a tape and you can see the splatter of the dye on the tape in that photo there. And we look for a very large droplet size. It must be a minimum of the ASAE coarse level, which is quite a significant droplet size, so that we're not actually putting a mist in the air, but actually think of it more like large raindrops that are falling from the boom of the helicopter. And what this means is it's much less likely to get picked up by the wind or by the velocity of the rotors of the helicopter and spread anywhere other than the target Phragmites population. Of course, we follow all the labels for the product that we're using at all times. That includes using wind speeds below 16 kilometers per hour. The helicopter must apply the herbicide no higher than 3 meters above the top of the plant. So that's less than 10 feet, so flying very low to make sure that application is very targeted, and at a very slow speed, about 60 kilometers an hour, which is about as slow as a helicopter can safely fly and undertake an aerial herbicide treatment. The nice thing about aerial application, it provides a really consistent and uniform application. It's very easily tracked with onboard GIS equipment. And it really is nice because it avoids having any foot pin on the ground from any other equipment at all. And of course, if you're going to use aerial treatment, like other methods of treatment, having a very experienced contractor is important. Just a little bit of what aerial treatment looks like. So I mentioned the onboard GPS tracking of all of the spraying that occurs when a helicopter undertakes treatment. This is a picture of work that was done in 2017 in the Turkey Point wetland complex under this project. You can see the orange flight lines of the helicopter heading out to the spray blocks and then heading north to the top of the map to the refueling and refilling area. You'll notice the lines change to a greenish yellow color as they actually, the booms are turned on and spraying the actual Phragmites. This is all done through a computer system. So we provide the Phragmites polygons to the contractor, and the spray software in the helicopter's GPS system turns the booms on and off, accounting for the height and speed of the helicopter to make sure that the application is very targeted, very accurate. And it also allows us to display exactly what occurred afterwards and make a map like this that is very good evidence and excellent for reporting. And lastly, that automatic boom system allows the pilot to focus on the safety of flying and less on the actual direct application. As I mentioned, though, a helicopter is not always the tool for the job in some unique sensitive areas that need a more targeted or precision treatment. And in that case, we hire a contractor to operate our ground equipment or our Marshmaster. In this situation, we have different conservation measures that are applied. Of course, all of the same particulars from the label apply around the weather and wind speed and timing and the personal protective equipment that must be worn. But we also have 2 operators at all times scanning for wildlife because we are actually now working in these sensitive systems. And so the exterminator, as you can see, is up high and has an excellent vantage point, and the driver down below has a large window in front of him and open areas to the sides where he can see and look for wildlife to avoid any potential for impact. It's also important to note that the way the work needs to be undertaken, it's a very slow process. So the Marshmaster moves ahead a bit, some treatment is undertaken by the exterminator up top while he stops, and then they move again to the next area and treat again. So it's a very slow move, stop, move process, which provides a good opportunity for wildlife to flee the site if they hear the rather loud equipment coming. Of course, we practice a single pass between Phragmites patches and try to drive within the Phragmites as much as absolutely possible. Because of the density of Phragmites, there's very little opportunity for wildlife to actually be within the patches. And so we try to maximize our travel within the Phragmites itself. And of course, we're avoiding any potential features that might be found out there that might be hiding wildlife. For example, rotting stumps and debris and rubble piles are excellent places for thermoregulation or overwintering for reptile species. More on the conservation measures. Everything on our Marshmasters is also tracked by GPS. We have tablets that show our GPS track lines. We're able to load up species at risk hotspots, any known wildlife features or infrastructure we need to avoid, so that the operators have all of that information at their ready and are able to avoid it while they're working on site. When we shut the equipment down, we are always taking a quick scan through it to make sure that none of the herpetofauna have made their way in there, in particular snakes, where they may have had the opportunity or interest in getting in somewhere warm to warm themselves up while we've shut the equipment down for lunch, for example. So taking a quick scan to make sure that nobody's made residency in the Marshmaster during our breaks is important. It may sound silly, but we actually apply the herbicide to the plant directly, and that's an important thing for folks to know. The herbicide, thank you, the herbicide is applied directly to the plants and not to the water. And we also use a very thorough filter for our water quality to make sure that we're having a very good efficacy when we apply the herbicide. And lastly, we need to clean our equipment when we leave every site so that we're not a source of expansion to the next property. A little bit about our methods here. We use a John boat as well, and sometimes we're spraying in the boat, but sometimes it's much less fun and the exterminator has to get out and run the hose reel out and spray those other areas that you just can't simply reach with a Marshmaster or the boat or the helicopter directly. So it's not all glory. There's a lot of hard work. A bit about our monitoring program. We are monitoring drinking water quality, so measuring the surface water at the intakes for all of the local communities. Of course, we look at the herbicide efficacy. Did it actually work and kill Phragmites? The University of Waterloo is also looking at what happens to the herbicide after we apply it in the water column and the sediment at the bottom of the lake and the marshes we're working in. We look at the impacts to aquatic organisms and effects on fish and fish habitat, all of which have shown no negative impacts whatsoever in the 5 years of this project. We're looking at the sensitive vegetation communities that we work in and how they're responding and changing following our application. And we're also looking at monitoring benthic invertebrates as an indicator for other species of wildlife. Following herbicide application, we also conduct rolling and burning where possible. And in some cases, neither are possible, and poor young fellows are hired like this to go out and manually cut down the frag so that we've gotten rid of that standing dead biomass and can see any regrowth in subsequent seasons. Just a picture to show it actually does work. You can see this area very green that the arrow's pointing to in the Long Point Crown Marsh shows an excellent return of native vegetation only 1 year after herbicide control. Lastly, thinking about where Phragmites is and what succession looks like, we've expanded the project to treat seed sources in the Big Creek watershed. It has 22 sub-watersheds, and we're slowly making our way up the watersheds in a phased approach, engaging landowners like yourselves and providing a free of charge Phragmites control service for all of the residents within the Big Creek watershed. That's governed by a project team of a number of the organizations you can see listed here. We have about 15 of them helping us determine the best ways to reach out to the Big Creek watershed residents. And that includes assistance from groups like ALICE and the Long Point Region Conservation Authority and the Biosphere Reserve Foundation, helping us really get out into the community and build those relationships and get as high a participation as we absolutely can. Last slide here. This is what phase 1 of the Big Creek Phragmites project looked like. So after going out and knocking on doors and doing mailing campaigns and getting landowners sign up, we create a GIS map that shows what landowners need to still be contacted, which landowners have agreed to control, what type of control will be needed, whether it would be wet or dry, where the properties are, the preferred access points, and contact information for the contractor so that they can speak directly with the landowners when they're coming on their private property to undertake treatment. We've now completed 3 phases within the Big Creek watershed as of the end of 2020, and we're still working on our map. So sorry, I don't have the updated mapping for you today, but that's with our GIS team right now. We will be expanding the project up the rest of the Big Creek watershed and potentially a little bit wider within the Long Point Walsingham priority place. And so we hope to engage as many of you as possible in controlling Phragmites on private land so that we've gotten those seed sources under control. And I would be remiss if I didn't thank all the people who have contributed to this project thus far. Our main partner has always been the Ontario Ministry of Natural Resources and Forestry in acquiring an emergency registration to enable the herbicide work. Environment and Climate Change Canada through CWS has been an incredible funding partner and is now an implementation partner on the national wildlife areas. Ducks Unlimited and Wildlife Habitat Canada have both provided funding and technical support. We've received funding from the US Fish and Wildlife Service. Bird Studies Canada has been a monitoring and implementation partner from day one. The Long Point Phragmites Action Alliance members have been incredibly helpful in building community support and awareness and helping with our public information sessions. And lastly, all the folks who have actually allowed us on their properties to make this work happen and to really achieve some positive conservation outcomes for the priority place and the biosphere. So thank you very much to all of you. We couldn't have done it without you. And with that, I am finished.
Oh, thank you, Eric. I love your mantra. I love my job. I love my job.
Yeah, I'm very fortunate.
Yeah, and thank you for your hard work. Obviously, it is very hard work, and I'm sure everyone here today is very grateful for the very important work that you are doing. I see one question, maybe we'll see. Eric, if we, this is, forgive me if I'm not saying your name right, Betty. Betty Chanyai. Eric, if we find frag not on our own land, how do we go about reporting it and who do we contact?
Hi, Betty. Nice to hear from you. I feel free to contact myself directly at the contact information on the screen right now. Also, for landowners interested within the Big Creek watershed, you can reach out using our specific email address for that part of the project, bigcreekfrag@gmail.com. So that's another way, but if you didn't get that down quick enough, feel free to take my personal contact information here and I'll make sure your observations are recorded correctly.
So another, just a very quick one before we move on to Cynthia. Eric, Madeline Sutton. Eric, do you have a sense of which native vegetation species have started growing back in the Crown Marsh? So we'll just take about maybe 30 seconds, Eric, and answer that.
Sure, and unsurprisingly, for the most part, what we're seeing is the cattails come back that have been displaced by the Phragmites over the last 20 to 30 years. But there is a great mix of pickerelweed and arrowhead, all kinds of interesting submergent plants as well, the typical ones you might expect to see in the Long Point Basin. Of course, on top of the natives, there are other non-natives that are making use of this newfound space with the Phragmites gone, including one that's on our radar called European frogbit. So we're seeing mostly native vegetation community return, but there are indeed some secondary invasions that will require management likely in future years.
Okay, so there is one more question, but we're going to wait until the end of the session. Amanda Lauder, she was one of our presenters in the past. So thank you, Amanda. We'll get back to your question at the end. Okay, so we're going to move on to our second presenter, Cynthia Toswell. Cynthia is pleased to present on behalf of Alice Norfolk as the Assistant Program Coordinator. She is passionate about conservation, specifically its role in sustainable agriculture. Cynthia resides in Norfolk County, just a stone's throw away from Priority Place. Her farm is home to numerous restoration projects, similar to those she will be discussing today as they relate to the Integrated Conservation Action Plan. Welcome, Cynthia. Thank you.
Okay, just give me 1 second here to get set up. Okay, can everybody see that?
Yes.
Wonderful. Okay, thanks so much, Tara, for the introduction. I'm happy to be here this morning talking about ALICE, Alternative Land Use Services, the Priority Place, the ICAP, and how ALICE is contributing as a member of various working groups. So my agenda for this morning includes an overview of the ALICE model, and then I'm going to move into some specific project types specific to Alice Norfolk. I'm excited to share with you our Alice Norfolk video premiere.
Oh, Cynthia, just to stop you, I think your screen stopped sharing.
Okay. How do we do this here?
So bear with us, everyone. Most of us, like Eric kind of alluded to, we're used to having hip waders on and out in the field. So, oh, there we go. Awesome. Thanks, Cynthia. Well,
How does that look? A little better?
Looks great.
Good. Okay, wonderful. So then I'm going to move into Alice and ICAP, and specifically in regards to agricultural runoff, and then focus in on the priority place with a project overview. So Alice works with local farmers and ranchers to meet the environmental needs of the community and provides farmers with an annual payment that supports them in maintaining habitats and ecological services over time. So our focus is on marginal land, not prime agricultural farmland. Alice is unique because the program is community developed and farmer delivered. Alice recognizes the important role farmers and ranchers play as stewards of the land and empowers them to deliver nature's benefits on the working landscape. So two of the most important principles of the Alice program are mentioned here, the fact that it's community developed and farmer delivered. And I'm just going to move on to the next slide here, which is basically an overview of the Alice principles. So right at the top there, we have community developed by local communities to be flexible and respect local agricultural and environmental priorities. Farmer delivered, farmers and ranchers are in the best position, we believe, to deliver nature's benefits on their land. The program is targeted, so select marginal and ecological sensitive parcels of land are managed in a different manner to produce nature's benefits. We are market driven. Benefits from nature produced by project activities have economic value. And the program is voluntary, which is a very important piece for a lot of our participants. Farmers and ranchers choose to participate and have flexible agreements that suit their operation. We are integrated, so delivery will complement existing conservation programs, including federal and provincial government policy frameworks. And we're accountable, so projects are independently monitored and audited. And last but not least, we are science-based, so social, economic, and environmental sciences guide program development and implementation. How does Alice work? So this is just a brief overview of the process, which I'll explain in greater detail throughout the next few slides. And that's me there on the right at our farm with our Tallgrass Prairie project. And that's about 3 years after it's been established. So I'll just run through the list very quickly, but then I am going to break it down in the next few slides. So it all starts with an expression of interest, followed by a site visit. And then we move into site plan development and budget planning. And then it's the proposed project is reviewed by our PAC, our Partnership Advisory Committee. And then we create a conservation agreement followed by project establishment. And then we have a site visit for quality assurance. There's actually a number of site visits throughout the process. And then we move into verification. And last but not least, we have the annual payment. So it all starts with an expression of interest, and this gives us a nice snapshot of the proposed project and property. Specifics include total acreage of the property, as well as the proposed project size. So that's really important to us to know some of the details in terms of lot size, cultivated land, orchard, pasture, because ultimately one of our guidelines is that in our decision making is that we don't want to take more than 20% of workable land out of production. So after the expression of interest, we have an initial site visit, and that is a good opportunity for us to discuss ideas and determine the best use of land, not only based on the topography of the land, but also the long-term goals and interests of the landowner. So if there is a viable idea, we move into site plan development and budget planning. This is where we engage partners and landowners. We collaborate on a site plan. We develop a budget and receive approval from the landowner and partners. Following the site plan development, we share the project idea with our PAC, our Partnership Advisory Committee. And we ask ourselves three main questions. Does the activity meet the ALICE principles? So those are the principles that I mentioned earlier. Are there more ecosystem services produced than before? And is there a clear line of funding that will support this activity? So just a note about ecosystem services, which I've mentioned a few times. I've also referred to them as nature's benefits. So ecosystem services are commodities such as cleaner air, cleaner water, erosion mitigation, improved topsoil quality, and reduced runoff of chemicals. So if the project is approved by the Partnership Advisory Committee, we create a conservation agreement, which is essentially a contract between ALICE and the landowner that explains the term of the agreement and roles and responsibilities of ALICE and the participant. We move on to project establishment. And this could include the establishment of a wetland or a grassland project or a reforestation project. And those are the three main categories of project types within our program. So site visit for quality assurance. Throughout the process, there are numerous site visits, and that's a great opportunity just to ensure that everything's on track, assure quality, and to have many conversations with the landowner and just keep them in the loop, obviously, of how things are progressing. And then last but not least on our list, we had annual payment. So this is for maintenance and monitoring. It's typically $150 per acre or $75 per acre if there is a modified agriculture project. And that would include things like delayed haying or grazing. And that's provided at the end of the year. So now I'm going to move into ALICE Norfolk specifically, which is the longest continuously running ALICE program in Canada. And as I mentioned before, we have three main categories of projects. We have wetlands, grasslands, and reforestation projects. So currently for wetlands, we have 103 wetlands created or enhanced in Norfolk County. We have just over 50 acres in the ground, wetlands specifically. And then we have grassland projects. So there are different types of grassland projects. This could include block plantings of tall grass prairie with forbs, meadow mixes, grass waterways, or modified agriculture practices, which I referred to earlier, such as delayed haying and grazing. For tall grass prairie, we have 294 grassland projects in the ground. We have 818 acres. And reforestation, we have 319 reforestation projects, which amounts to 636 acres in the ground. So reforestation projects could include windbreaks, upland block plantings, or wetland buffers. So as a summary, we have 184 participants in the program. We have over 1,100 projects, and we have 1,500 acres in the ground and growing. So now I am happy to share with you our ALICE Norfolk video premiere. This was actually put together just this past summer, and it features projects on my farm, as well as Joe Chaffe's property, who is the ALICE Norfolk PAC chair. It was put together with the help of videographer Greg McLaughlin with Work Cabin. The purpose of the video is to provide a visual summary of our program, and it's also a great outreach tool.
ALICE works with local farmers and ranchers to meet the environmental needs of the community and provides financial support to farmers to assist with maintaining habitats and ecological services over time. Located in the heart of Carolinian Canada, the ALICE Norfolk program has over 1,500 acres enrolled in various restoration projects, including tallgrass prairie, wetlands, and reforestation. We're proud to collaborate with partner organizations and researchers. Through collaboration, we are making a significant impact on the landscape. It's about restoring marginal farmland while maintaining the important balance between conservation and agriculture. Alice Norfolk is one of many communities supported by Alice Canada, a national charitable organization that supports the delivery of the Alice model across the country. Reach out to us to learn more about producing acres of cleaner air, cleaner water, wildlife habitat, and other ecosystem services.
So I hope you enjoyed that, and I have to give a big thank you to Elaine Ho, who is presenting later this morning. She was a big help to me, helping me embed that link to the video so that I was able to share it with you this morning. So now I am going to move on. That's not what we want to do, that's what we want to do. Alice and ICAP. So for those of you, as some of you already know, ICAP stands for Integrated Conservation Action Plan. And our focus today, of course, is the priority place, the Long Point Walsingham Forest. The vision of the ICAP is healthy, resilient, and connected ecosystems that support biodiversity, productive landscapes, and a thriving community. ICAP funding is provided by Environment and Climate Change Canada. The purpose of the collaborative is a partnership of non-government and government organizations that are committed to improve biodiversity conservation in the LPWF. And Tara spoke briefly about the priority place earlier and basically addressed the definition, which I'm just going to share with you again. A priority place is an area of high biodiversity value that is seen as a distinct place with a common ecological theme by the people who live and work there. There are 11 priority places identified under the Pan-Canadian approach. The places selected have significant biodiversity, concentrations of species at risk, and opportunities to advance conservation efforts. So within the ICAP, we have 5 working groups. The invasive species group, which Eric addressed before my presentation. We have the agricultural runoff group. We have the road ecology group, fire suppression, and the forest and treed swamps working group. So Alice is actually involved in the agricultural runoff group, as well as fire suppression and forest and treed swamps. But for the rest of the presentation this morning, I'm just going to focus in on agricultural runoff. So why?
Cynthia, just to jump in, it's your 5 minutes.
Thanks very much. So why is Alice a good fit? Because our program focuses on agriculture, which is the main land use and sector in LPWF, accounting for approximately 47% of the area. Agricultural runoff refers to the byproducts of farming practices that result in degradation of watercourses and wetlands. So runoff can include pesticides, including neonicotinoids, fertilizers, and cattle manure. This can enter waterways, wetlands, and open water, reducing water quality and sour habitat. These effluents contain nitrogen and phosphorus, which eventually accumulate in Lake Erie and contribute to eutrophication. So Alice Norfolk is currently receiving funding through 2 different streams from ECCC. Both funding streams are for 3 years, and stream number 1 began in 2019, restoring and managing natural ecosystems on marginal farmland in Ontario's priority place, Long Point Walsingham Forest. So the focus is ensuring proper management and protection of over 1,300 acres of conservation projects on marginal farmland, and funding allows landowners enrolled in the program to carry out necessary maintenance required on projects, and that can include things such as treating for invasive species or conducting prescribed burns. So the second stream, which began in 2020, is species at risk partnerships on agricultural lands in Ontario's priority place, Long Point Walsingham Forest. So funding within this stream is permitting us to establish new conservation projects, which I'm going to address in more detail in the slides. So the funding under Stream 2 enables local conservation groups to effectively work towards reducing the threat of agricultural runoff across farms in Norfolk County. So funding and work plan activities are shared amongst the following partners: Alice Norfolk, Long Point Region Conservation Authority, Norfolk County's Drainage Department, and Carolinian Canada. So within that group, Alice Norfolk is using funding to establish new projects on marginal or environmentally sensitive land and ensure they are managed for the duration of their conservation agreements. LPRCA oversees cover crop establishment, as well as the establishment of wetlands and reforestation projects. Carolinian Canada is focusing on outreach in order to engage landowners in restoration and BMPs. They are also connecting landowners with appropriate local organizations based on their restoration interests. In addition, they also carry out small-scale restoration. The Norfolk County Drainage Department oversees the majority of drain buffers and enhancement, and our objectives share an overriding goal of reducing agricultural runoff. And we, Alice Norfolk, is very happy to take the lead on the administration and organization of the projects and funding. So just to reiterate, funding allows Alice Norfolk to establish new projects on marginally and environmentally sensitive agricultural land and ensure they are managed for the duration of their conservation agreements. In real working terms, it will play out through establishing wetlands, reforestation projects, grassland projects, as well as cover crop projects and outreach within the community. So main targets of the Agricultural Runoff Working Group to be achieved by 2023. Number one, restore 116 hectares of new natural features, preserve 50 kilometers of drain corridors through modified practices, promote BMPs to over 500 landowners, and number four, plant 263 hectares of cover crops across more than 15 farms. So now I'm just going to share with you a real life example within the priority place, a project overview that was shared with our Partnership Advisory Committee last month. So an existing Alice Norfolk participant would like to plant a small marginal and slope section of his field into trees. So that's what we've got right here on this map. Right here. So this section would nicely square off the field, allowing the landowner to farm more efficiently. Last summer, the landowner treated a patch of Phragmites with herbicide and will monitor weed growth at the proposed reforestation site and treat accordingly prior to planting. So he was also able to provide this image here. So this little divot, which shows a very low yield, crop yield, correlates to this area here. So the plan is to plant trees mid-May by hand. They would be scatter planted. They would be planted 7 to 9 feet apart. And of course, they would include a variety of native species. So the project helps to minimize erosion while also providing habitat for wildlife and extending an existing wildlife corridor. So the project was approved and ICAP funding will be used to put the project in the ground. This is a great example of how Alice will make a difference in the priority place thanks to ECCC funding. So I'm happy to take any questions. I did just want to show 2 more slides very briefly. This is just a list of Alice contacts and partners that comprise the Agricultural Runoff Working Group. There's myself, Steph Giles, the Alice Norfolk Program Coordinator, Joe Chafe, the Alice Norfolk PAC Chair, Paul Gagnon with LPRCA, Morgan Van Laken with Norfolk County Drainage Department, and Michelle Cantor with Carolinian Canada. And I would like to give a very big thank you to the Long Point Biosphere for organizing this year's conference, working group partners, panelists, and viewers who tuned in today.
Thank you, Cynthia. Very important for the landowners to be involved and also the priority place with being surrounded by agriculture down here in Norfolk County. And what an awesome video. That was really nice.
Oh, thank you.
That's really great. There is no questions. I think we're going to take that as a compliment because everybody seems to know Alice and what you guys are up to. So thank you very much for all that you do, and especially with the priority place initiatives.
Thank you.
Okay, thank you, Cynthia. So we're going to move on to our next presenter, which is Michael McTavish. So Michael McTavish is a Metax Elevate postdoctoral research fellow working with the Smith Forest Health Lab at the University of Toronto, Agriculture and Agri-Food Canada, and Ducks Unlimited Canada. His research looks at the novel ecological interactions that arise from biological invasion and their implications for conservation management. His current research includes implementing insect-based biological control of introduced common reed and garlic mustard, and the ecology of exotic earthworms. Wow, interesting stuff, Michael. Awesome, welcome, and thank you.
All right, thank you. Just gonna get this going here. Everything's looking and sounding good? Okay, perfect. Thanks very much. Very happy to be here. So we're going to take things back to our favorite species here, Phragmites. I'm going to be talking about some work that I've been doing with Dr. Sandy Smith from the University of Toronto and Dr. Rob Boucher from Agriculture and Agri-Food Canada. And so what we're looking at today is the work we've been doing on developing biological control of induced Phragmites in Ontario at a pilot scale. So the challenges of introduced Phragmites are probably and unfortunately quite well known to many of the people here today. Eric's also done a great job earlier of already laying some of this groundwork. So to just very briefly reiterate this, we're talking about introduced Phragmites. So this is Phragmites australis, specifically the australis subspecies. It is considered one of the most invasive plants in North America. Thought to have been introduced in the late 19th century. It's continuing to spread across North America. It's a very familiar sight in many built environments, but also many more natural areas as well. This is a species capable of forming very dense, nearly monospecific stands, which have various ecological and socioeconomic harms, including potential reductions in biodiversity, altered ecological processes, reductions in aesthetic and property values, and things like sightline impairment and increases in fire risk. And so due to these various harms, there's of course great interest in tools for managing these populations, and various control options do exist and can be very suitable in different contexts. But for each time they do sort of get the job done, there'll be other situations where they are inadequate for some reason. In certain cases, they may be limited in their effectiveness. They may be expensive, and they can pose various risks to off-target species, to people, and to various other environmental factors. And so for these reasons, there is a critical need for additional control options to supplement the existing management tools. And that takes us to this concept of biological control, which we're looking at as trying to put another option in the toolbox. To give a brief general overview of biological control, or biocontrol broadly, this refers to the use of live organisms to suppress an introduced pest, in this case, insects for a weed. Why consider biological control? Weeds like Phragmites are generally introduced with fewer natural predators. So biocontrol is about attempting to reunite that weed with some of those predators and reestablish some of that natural balance that keeps these populations in check. Ideally, these processes become fairly self-sustaining once insects are reproducing and are able to hopefully track the host to some extent through both space and time. Because of this self-sustaining nature, ideally, biocontrol programs are fairly cost-effective at large spatial and temporal scales. They also are designed to be highly host-specific. So the idea is that the host is only going after the target, and so you have very few off-target impacts and low environmental impact overall. Despite these many advantages, biocontrol is often turned to as something of a last resort option when compared to other things like herbicides or cutting, burning, or maybe even doing nothing at all. And realistically, when we're trying to compare the risks of these different management tools and decide what the best choice is in any given situation, the risks of all these options really need to be compared against each other, as all do bear some sort of risk, but also against the cost of doing nothing, which for Phragmites we know to be quite high. Importantly, no single approach, and that includes biocontrol and any other, is going to solve the problem. So we're not talking about which of these is going to be best. We're instead looking at providing an additional option in this expanded integrated pest management or IPM toolbox. The realistic goal of any biocontrol project, including this one, is not complete eradication. Instead, we're looking at added pressure that ideally decreases weed populations over time. And so that can interact with other management interventions or resistance from native biodiversity that's in the area. So this is very much a long-term solution that can take many years to implement and many years to see larger scale responses from. So this takes us to specifically biological control of introduced Phragmites. In North America, this is a program that's actually been in development for over 20 years. So there's a lot of work has been done on this. The initial explorations identified 175 candidate species of European natural enemies. So these would be pests of Phragmites in its native range. Over time, these were narrowed down to 2 candidates that are being used now. These are 2 stem-boring noctuid moths shown here, Arcanera neurica and Linisa geminipuncta, formerly in Arcanera as well. So both of these moths are natural pests of introduced Phragmites in its native range. To give a general overview of the life history and impacts of both these species, which are very similar, these are stem borers, so the larvae hatch and will mine shoots in the spring and the early summer. This feeding damage from the larvae in the shoots causes stems to typically wilt above the point of feeding damage. So in younger stems, you will see stem mortality, they'll die. With larger stems, you'll get reductions in height and reproductive output. The pupae then complete their development within the stems themselves. And finally, adult moths will emerge, mate, and lay eggs under the close-fitting leaf sheaths of the plant. So the eggs will overwinter in this secure location. An important part of any biocontrol program, including this one, is extensive host range testing to ensure a high degree of specificity of the agents to the target, in this case, Phragmites. So this involves extensive testing in both the lab and in the field with experiments where insects have a choice between plants or no choice and are forced onto certain ones, and looks at various responses, including how they survive, oviposition, performance of the plant, and so on. So this work was carried out over many years at CABI, largely by CABI in Switzerland and at the University of Rhode Island. This testing involved 46 species, which covered a range of different taxa. So these included native and introduced species, species that were commercially significant, such as crops, species that were ecologically threatened, or phylogenetically similar to the target. And this included native Phragmites. So this is, as you may be aware, one of the added complications of the Phragmites story is the presence and conservation value of this native subspecies, Phragmites australis americanus, which is very closely related to the introduced form. This is a species that again has this conservation value, but is already thought to be threatened by competition with and hybridization potentially with introduced Phragmites. So this is a situation where we don't want to add to the troubles of native Phragmites by the agents that we're introducing. So testing for a high level of subspecies specificity so that they're going after the introduced form and not the native has been a major focus. To give a general summary of the host range testing that has been conducted, it's good news. Both insects are highly specific to the Phragmites genus, and there are a number of both morphological and ecological reasons for this. Amongst other things, the insects do require a minimum diameter of stem in which to complete their development in, so anything too small is just not going to work. Also, very importantly, the eggs do require these tight-fitting leaf sheaths under which to overwinter. So anything that can't provide that isn't going to be a good host. In terms of comparing preferences for the native versus the introduced lineage, this is also a good news story, where there seems to be a very strong preference for the introduced lineage. This is primarily due to that leaf sheath situation that I just mentioned. So native stems tend to drop their leaf sheaths in the fall and winter, and so they can't really provide any place for the insects to overwinter, and they can't complete their life cycle effectively. So in choice experiments, a very small number of eggs will be laid on native stems, but it's a very small number, and the eggs that are present experience very high mortality. So we're sitting right now at the endpoint, or the current endpoint, of approximately 2 decades of research and development. So again, this started with these initial proposals and talking about this back in 1998. That was followed by several rounds of surveying for insect candidates that were eventually narrowed down to the 2 that we currently have. Many years of host range testing were carried out, followed by a joint Canadian-US release petition put out in 2018. This was approved in Canada by the Canadian Food Inspection Agency in 2019. And then that brings us to the present day and the pilot program that we are putting in place here in Ontario. So this is where my involvement in the project begins. This was started in summer 2019, and I'm going to talk a little bit about some of the current and recently past projects that we have. The primary research goal of all of this is essentially to implement on-the-ground biocontrol of introduced Phragmites in Southern Ontario at a pilot scale, essentially figuring out how we do this before we scale it up. And this is using our 2 species here that we have. This research goal can be unpacked into essentially 3 main research objectives, which are to develop, implement, and test agent rearing and storage protocols. So how do you actually rear large numbers of insects in the lab, and how do you store them to synchronize large releases in the field? Agent release methods and nurse site establishment. So once you have them, how do you actually put them out onto the landscape and establish these nurse sites where populations are present that you can then go back to and resample and recollect from? And finally, monitoring protocols to assess agent release, establishment, and impact. So once they're out there, how do you know how they're doing and the impacts that they are having? So these objectives give rise to a number of different priority questions that we're trying to address during these pilot trials. So examples of some of these leading questions will be things like, how do we actually feed larvae in the lab? How do we rear them? So we've been experimenting, for example, with different formulations of artificial diets involving different amounts of field collected vegetation. Importantly, under what conditions and for how long can we store the eggs? So once you have the insects, you want to be able to stockpile large numbers so you can put them out. So learning more about what temperatures to use for that, where to put them, and how long you can store them in this fashion. Once you have the insects, again, you actually need to be able to put them out. So how do we introduce insects into the field is a big question. Related to this is, what life stage do we actually release them as? So in this case, we have the options of putting them out as eggs, as larvae, as pupae, or as adult moths, and each tend to have their own pros and cons with them. Once they're out there, there's also this important question of how do you actually protect them from deleterious factors such as weather or predation. And finally, once they're out, how do we actually measure and assess establishment and impacts? How do we know that they're there? How do we know what they're actually doing? How do we know how surrounding vegetation is hopefully recovering? One of the big questions as well going forward will be how far and how quickly do established insects actually disperse? So once you have a population, how in what manner do they then spread to different areas? So these and other questions are being addressed through 3 main completed and ongoing or upcoming projects since summer 2019. And I'll step through these here quickly. The first goes back to summer 2019 when I became involved with this project. I conducted a survey of both native and introduced Phragmites populations along a sizable gradient of southern Ontario. These included field surveys of 63 sites. And the main idea here was to find and characterize different regional lineages. So between native and introduced populations, we know that there are diagnostic differences in their genetics and in their morphology. These are known from different areas, but it can vary regionally. So we have to have a good idea of what we actually have in our own backyard. This also provides an excellent opportunity to identify candidate sites for experimental releases and to establish some of these nurse sites that I had mentioned. This summer, despite the restrictions imposed by the situation, we were still able to conduct a preliminary egg storage and release trial experiment. So this consisted of preliminary releases at 2 Ontario field sites. So we were experimenting with putting out insects as eggs in this case. So we compared primarily the hatch performance of 7 different groups that were comprised of the 2 different species that we have, mixed with different diets that they were being fed, and different overwintering conditions we were experimenting with. One of the things that we realized very early in these trials that when putting insects out as eggs, they were exposed to a very high degree of predation from, we suspect, ants and spiders and such. So learning how to protect those eggs from that predation using different methods was one of the main focus here. So you can see in these photos in the bottom right, some of the different methods that we are experimenting with. And finally, we come to the work that we're preparing for going forward into spring and summer 2021. We're planning additional overwintering and larval release trials. So the idea is to conduct additional releases at 2 more Ontario field sites. We'll be focusing this time on releasing insects at the larval life stage. And we will be comparing how they establish after they have experienced 3 different storage regimes. So we're currently storing them as eggs in outdoor conditions, indoor controlled growth chamber conditions, and then we have a 3rd group that will be coming to us from overseas at the very last minute, and we'll be seeing how these 3 different treatments perform. As mentioned before, we're very much interested in what dispersal looks like after establishment, so we will be mapping around the release points and monitoring to assess post-release dispersal. So I just want to wrap up on a few closing thoughts here. Starting with some general reminders about biocontrol, as this can be something of a new tool for some people. One of the big things that I've emphasized already is that this really is about implementing a long-term solution for a large-scale problem. And Phragmites is very much a large-scale problem. So when we think about arguable biocontrol success stories, such as control of purple loosestrife, this is something that was implemented in the 1980s and is really ongoing to the present day. So these take a long time to implement and a long time to have these large-scale impacts. The objective is, again, not immediate or complete eradication. It's about extended pressure over time. When trying to decide on appropriate management interventions, the assessment of risks must include the costs of other management and, very importantly, of no action at all, which for Phragmites is high. And finally, like any control or management option, this should not be regarded as a panacea. This is instead ideally an additional option in the integrated pest management toolbox. Given the scale of the Phragmites problem, we really need as many tools there as we can get. And so this is currently at a research pilot stage, as I mentioned before. What we're really trying to do is just develop basic operational techniques. How do we get this on the ground? So going forward, we'll be looking at scaling this up in terms of rearing and release and looking at broader implementation. So there are really going to be some exciting years ahead with this project. So stay tuned for that. And so this is a large project, of course, with many collaborators and supporters. We appreciate that very much. Some of our long-term and very appreciated partners include the Invasive Species Centre, the Ontario Ministry of Natural Resources and Forestry, Nature Conservancy Canada, and my own participation in this is supported by a MyTax internship with Ducks Unlimited Canada. Thank you very much.
Well, thank you, Michael. Very interesting research, and it's amazing to see all the collaboration here, like you said, all working together to mitigate this really highly invasive species, especially when you come down to Long Point. So thank you, Michael. Okay, so we're going to move on to our last presenter of the morning. And Elaine Ho. Elaine Ho is a PhD candidate at University of Waterloo and a member of the Lake Futures Group in the nationwide Global Water Futures Research Program. Her research strives to develop a coordinated freshwater monitoring, management, and decision-making framework for the estuary of the Lower Grand River and nearshore Lake Erie. As a part of her research, she developed a new process for selecting and prioritizing monitoring indicators and has used the arts to engage with often excluded demographics. Elaine is currently exploring approaches for assessing cumulative effects in water monitoring data. Very interesting to put the arts in there. Good morning, Elaine, and thank you for joining us.
Thank you, Tara. I'm just going to share my screen. Hopefully that is there. Is everyone able to see the screen?
Looks good.
Okay, perfect. Okay, so as everyone knows, my name is Elaine. In this presentation, I'm going to share some high-level outcomes from what has now become a 5-year study that's in its final stages. If you want any more detailed information about anything in this presentation, because it's going to be pretty action-packed, I do include a lot of links on the slides, and also my email address is there. So if you want to follow up or get clarification or anything, then feel free to email me. Okay, so the study goal was to propose a monitoring framework that considers cumulative effects, is co-created by diverse stakeholders and rights holders, and which connects monitoring to management decisions. Now, the study was developed for the Grand River estuary, which is the area in the Lower Grand River and nearshore Lake Erie, where you can see influences from both the lake and the river. However, this work is relevant for the Long Point area as well, because both regions hold significant ecological and cultural value. They have unique mixes of very different habitats and ecosystems, as well as management being complex in their own ways in each area, with some similarities due to sharing the influences of the eastern basin of Lake Erie. But of course, in Long Point's context, you also have influences with the Central Basin. But there are many aspects of the proposed framework that are broadly applicable, not just to both of these regions, but for other areas in Ontario and in some cases outside of Ontario as well. So as we completed the initial stages of the research, it soon became clear that one of the most important questions to ask ourselves was whose values matter for determining what we monitor. So if you attended last year's conference, you might remember I proposed a different process for selecting monitoring indicators that is more inclusive than current processes. And this is a screenshot from one of the slides, that diagram. So the PDF slide deck includes links to further information if you're interested. But the question of whose values matter highlighted the lack of diversity in current approaches, which then resulted in the question, how do we ensure diverse values are considered? And this is what the rest of this study focused on. Although value systems and engagement processes may not be the first thing that many people consider when designing conventional monitoring programs, we realized very quickly that there are many reasons to introduce diversity into any future monitoring and management endeavors. First, the challenges we faced and will face are increasingly complex and in some cases recurring. So we need to try different approaches and apply different knowledge than we have in the past. Second, over the last century, communities worldwide have been diversifying as a result of human migration, so that's settlement and resettlement. So management must consider these changes as we continue to develop. Third, demand for accountability is increasing worldwide. So there are trends in regions across the globe towards open data and more transparent processes, while tolerance about inequities, including the lack of action on Indigenous reconciliation, is decreasing. And many of you may be aware of some of the things happening in Canada right now with the Mi'kmaq on the East Coast and many other issues across the country. So that's all ties into this. So when we do recognize diversity and collaborate with communities, risks and costs are shared while benefits are enhanced and experienced more widely. Which brings us back to our second question, how we might consider diversity in water monitoring and management. In addition to the indicator selection process introduced last year, there are many ways in which diverse persons can be engaged in water monitoring and management, but only a few can be explored in this study. The culmination of the study was to engage the Canadian public and Indigenous youth via the arts in order to bring forward different knowledge that is conventionally used to inform water management. community workshops were held in which the public contributed to various kinds of artwork that would be permanently installed in their neighborhoods. The sturgeon in the photo is hanging at the Port Dover Harbor Museum and was made with glass mosaic tiles and plastics collected by community members from the Norfolk area shorelines. This was more of an awareness building and conversation starting exercise, but surveys were also given to participants to assess what the community's priorities are. Indigenous youth then contributed to a virtual art exhibit in which their water-themed creations were accompanied by their own stories to describe what their relationships were and beliefs about the water system. The exhibit is currently being held at the museum in Kitchener, where about 50,000 people are expected to visit over the 6-month exhibit period. We also have shared highlights of our study in various ways, and this is part of the education building across the region. So this includes industry magazines like the fall edition of Water News, which is published by the Canadian Water Resources Association. And they also featured us on the back cover, which was a nice surprise. And we also have a story in the current issue of Water Canada magazine, which is freely available for everybody to access if you'd like to read that article. And it has a broad readership, including many municipalities. So that brings us one step closer to bringing these insights to the decision makers and local authorities. The youth's written stories in the Grand Expressions exhibit were then used to create a basic set of principles and values that would be the foundation of the proposed framework. So their list was combined with principles and values from other phases of the research, including interviews with past and current practitioners and subject matter experts to create this summarized list. Developing a set of community-derived principles and values that underlie monitoring and management is just one approach for ensuring community priorities, values, and principles are considered in all future endeavors without having to constantly re-engage with the community, because this is a resource-intensive pursuit. Ideally, engagement to develop this list would be comprehensive at the start and updated every decade or so as the community evolves. On a related note, other work has recognized that Indigenous perspectives are especially underrepresented in the natural sciences. This acknowledgement over years of study has led to collaboration of frustrated Indigenous and Canadian researchers to publish 10 calls to action for natural scientists in Canada. Their paper was published on October 1st and is publicly accessible. So if you're interested in reading the calls to action, I've linked the publication here, and I also recommend it to all the academics in the audience. But also I'll be working on a paper in the next couple of months that connects the Sustainable Development Goals framework to water management for this purpose as well. So if that's of interest to you, you can feel free to reach out to me and I can update you when that's available. Now we'll take a high-level look at the draft framework because it is in revision until February, so I can't give you full details just yet. All results of the study are published as they're available on my research website, which is linked on the first and last slides of this presentation. The framework was created largely from consulting with or interviewing seasoned practitioners and subject matter experts, as well as input from a workshop that I held on October 5th. We will only take a quick look, but there are many other details that are not shared in this presentation. So if you're interested in what this framework might look like in more detail, please follow up with me and I'll discuss this with you. So that is a high-level look at the structure of personnel. Leadership consists of two groups at the top there. The steering team and coordination team. The steering team drives the process and is a diverse group of representative monitoring partners or representative of the monitoring partners and community interests. The coordination team of monitoring persons, not just monitoring persons, but the coordination team ensures there are minimal gaps, duplications, and miscommunications across the monitoring partners and anybody else involved in the program. Program capacity involves the funds, training, and equipment, as well as expertise, but most of these are managed by the different parties in the program. So the funds committee is the only designated group related to program capacity. And this is responsible for identifying and pursuing sources of funding to ensure the program can continue. Of course, it is a monitoring program, so the main goal is to produce information, which is the third realm of designated roles, and that's that blue horizontal line with the three boxes, yellow boxes there. So those who contribute to monitoring, whether they're formal partners or community members like citizen scientists, are not necessarily a clearly defined subset of personnel, but they're the whole collective of individuals and organizations involved in the collection of data. So that box represents all these different groups, not just a specific committee. The data team helps to analyze and interpret the data wherever needed, specifically in the case of citizen science, and knowledge brokers will help to facilitate the creation of communications and to help ensure information gets to the people it needs to reach. I should also mention that the most critical aspect of this framework is the heavy involvement of community members, groups, and Indigenous communities, none of which are meaningfully engaged in Ontario right now in common practice. This framework represents a shift in responsibility, essentially, for freshwater resources, from being entirely the domain of government agencies to being a responsibility that is shared with empowered community members and groups as well. So from personnel, now we're going to look at the process, which is based on adaptive management. So there are 3 to 5 year reviews of the entire program, and that's shown in the blue line or blue arrows. As well as shorter iterations of annual or biannual check-ins that are shown with the green process in their sub-process. Shorter iterations involve status updates and addressing challenges, while longer iterations consist of a review of goals, success criteria, alignment with management, and more. Ideally, the longer reviews will coincide closely with turnover in provincial government, since inland water in Canada, except for the Great Lakes, is the jurisdiction of the provinces and territories. All activities are guided by the set of principles and values that I described earlier, and a lengthy stakeholder identification and classification process will have been completed early on. Because of this, we recommend a 2-year design phase, which will mostly involve relationship building and establishing a common mindset for everyone. So how is what I propose different from what already exists? I can make the detailed framework breakdown available to anyone interested, and it will also be available on my website, but there are 4 main changes that this framework represents. First, there is much more engagement of different demographics than normally occurs. Monitoring partners are conventionally defined as scientists or government agencies, sometimes with consultancies or industry partners, but this framework incorporates all the different groups and people that you see on the right there. Processes are more transparent. There is acknowledgement of other cultures and respect for their histories and what they have to offer. Capacity is built among all partners, which includes training, staffing, access to equipment or services, and funding is provided and shared between all the partners. And of course, finally, mechanisms for accountability have to be built in. A significant effort is put into relationship building, as you can probably see by now, which means that power dynamics must be consciously considered. Roles and influence within the collaboration are not delineated by legislated authority. Instead, they are largely self-determined in consideration of a small set of standard criteria or justifications. These may include what your vested interest is, which is established early on in the process, as well as your ability to change or flexibility to change when required, and whether you have the capacity to deliver on your commitments. So considering all these, the different parties are able to define what their own role is going to be. That relationships are prioritized over deliverables is not entirely unique to this framework, as there are examples of various agencies in Ontario that have implemented this approach long before this study. However, this is not common practice still, and so it is highlighted in this framework as a key component. Of course, due process, timelines, budgets, and deliverables are not completely disregarded. Instead, the various accommodations or adaptations may be needed to ensure that all parties are able to effectively work with each other. Further, there are many other mechanisms or components that are often lacking or out of scope for current monitoring programs and management structures. These are just some examples of key pieces that are formally incorporated into the framework. One of the challenges within my research was that reciprocity was out of scope for a lot of organizations. So even though working with Indigenous communities requires you to give back for what you're receiving, a lot of different partner organizations or collaborating organizations who hadn't originally planned on certain reciprocative activities may end up saying, well, we didn't really plan for that, so we can't really commit to it. And that's a little bit of a problem. So finally, we've learned many lessons along the way, and I'm going to briefly describe a few here. First, time and experience has shown that specialist knowledge is not the only thing that matters, which I think many of us know. Diverse perspectives are required in order to gain a complete understanding of the systems we're attempting to manage or to generate impactful solutions. Second, and this applies mostly to research, we encountered challenges regarding whose ethics system our study was being evaluated on. This was problematic when the University Ethics Board required formal, usually written consent to participants in the study, which in our case required potential participants to read and sign a 4-page information document. So this was not really conducive to the way our Indigenous community does things, and the required process actually supports colonial practices. So we held several discussions with our reviewers to have to find an acceptable medium. Third, historically negative relationships between Indigenous communities, and in our case, the Indigenous community we worked with, and Canadian researchers meant that there were certain preconceived notions that I had to overcome as the individual building the relationships. So in this context, I cannot stress how important it is to follow through on commitments, be completely open about what you're doing and why, and to ensure that the partners know you are open to changing your plans within reason to support mutual benefits, and you have to be open to change. And this relates to that reciprocity thing. Fourth, many of us are guilty of making assumptions, whether we recognize it or not. So for example, monitoring personnel and decision makers that I interviewed felt that each side often does not communicate with one another because they feel like they know what the other needs already, making communication redundant. So to overcome our limitations and assumptions, it's critical to engage with any interested parties early on if they're willing to engage with you. And if they're not willing to engage, it's equally important to find out why they aren't willing to engage. Finally, collaboratively created spaces, co-created spaces and solutions are critical for implementing long-lasting and effective programs. This is different than inclusivity. A lot of folks like to focus on the concept of inclusivity, but this is not the same thing, because inclusivity involves inviting groups who were previously not engaged into a social environment that was not designed for their involvement. So this doesn't necessarily, but often impedes their full participation and prevents innovations from happening, which diminishes benefits shared by all. Whereas on the flip side, just shared spaces are usually entirely new social environments that are designed to ensure all parties can meaningfully contribute to shared goals. So rather than asking the Indigenous youth to sit in on formal interviews like I did with the Western water managers, I asked the youth coordinators in what ways would be most culturally appropriate for the young people to share and express their relationships and their views, and what they'd like to see out of that. So I could have just gone in and done a quick interview and left, but not only did we put it into artwork format, I also ended up spending hundreds of hours working with various venues and museums across multiple cities to get their work to be featured in different locations. Because one of the things that they wanted to see was to showcase their voice and to be able to share their stories with other people in the local communities. So that was something that I took on, not for my research, but for the point of the relationship. And that's an important thing to recognize. Of course, COVID happened and none of that mattered in the end, but it did build a relationship in a way that other researchers in my group were not able to do. So that was a blitz presentation of high-level concepts, but I hope maybe some of it sparked your interest, and I would be happy to carry on this conversation further with anyone who's interested in doing so.
Thanks, Elaine. I love your lessons learned. Excuse me, I love the lessons learned. I wish more people would go in that direction. And also, I think me and maybe some others would love to go check out the exhibit, Grand Expressions, was it? Awesome, that sounds really amazing. And it makes me think water is life. And I really appreciate the diversity of your imperative research and how you're kind of, you know, for lack of a better description, looking outside of the box. Really, really awesome, really, really amazing.
I will put the link to the website in the chat in a moment. So
yes, great, because I think there is maybe a few questions, but that's not coming up on my thing here, so. Okay, so I want to thank everyone for participating today and joining us, and I would really like to thank our sponsor, Environment and Climate Change Canada, and to let everyone know, if you haven't heard it a few times, that the webinar was recorded and it will be up on the Biosphere's website. So if you want to look at A1's slides in particular to find out different links like Elaine was mentioning along the way, then please do that. This is different this year. I love the networking, and I'm hoping that we can network in a different way. To me, that is extremely important. So we hope to see you this afternoon, and I know that weather out there is very tempting. So I really appreciate sitting and being with us today, but everything we've heard about this morning is so absolutely important. Like I said, not only to Long Point, but to everywhere. And to me, I think of our children's future, because that's what we're doing this for ultimately. So if we don't see you this afternoon, have a great weekend. I'm hoping to go kayaking. And we hope to see you at next year's Research and Conservation Conference. Whether we do it like this or otherwise, we hope to see you, and I'm just very thankful. Thanks for being with us, and hope to see you this afternoon.